SysCore is an umbrella organization for both universities that captures the study of robotics, intelligent systems, controls, all things that have to do with how robots and machines interact with the world that we live in.
Here at the Optimal Robotics Laboratory, we focus on controlling robots. How do we make them smarter so they can get around in our world while getting along with us? Our worlds are complicated. We do all kinds of crazy things that the robots don't expect. We get in their way, we put something in front of them, but how do we make them think in a way where they work with us instead of getting in our way?
I primarily focus on bringing new robot designs to life. So we see a lot of humanoids and a lot of quadrupeds, things that look like people, things that look like dogs run around nowadays. That's not to say that that's necessarily the best morphology. So I work on new designs that incorporate different arm mechanisms, different legs, and try to create new robots that are better at different tasks. For example, we're working on a bomb disposal robot. Current bomb disposal robots on the market look like tanks with arms on them, and what we want to do is improve their agility so we get the abilities to climb over obstacles like those dogs and humanoids, but we have the efficiency of wheels. Our hope is that these robots are going to go out and save lives.
My main focus is on multimodal robotics, or robots that are capable of traversing different terrains, such as walking on land, swimming in the ocean, or even climbing different substrates such as rock, a carpet wall behind me, fences, things you would see in the real world, and having all of those capabilities on a singular robotic design. The robot that we demoed earlier today is our Selkie robot, or our Seafloor Environment Legged Quadruped Intelligent Explorer. Selkie is designed to be a quadrupedal robot capable of exploring the seafloor or benthic environments to find things such as underwater cables, as well as looking around at different soils and sampling.
I am working under the One Accord Lab, which stands for Autonomous Collaboration and Robot Design, with Dr. Moore as the director. Currently, I'm working on a transmission device for 3D printing. My device, you can change and smoothly transition through almost a near infinite gear ratio using my device, and that makes the system more precise and more affordable. Through that, we can improve the resolution of the 3D printers out there.
In Rhythm Lab, where we work in projects that are related to human-robot interaction. The project that I am working on is called Context-Aware Intent Inference. We're trying to predict human intent by being aware of the context and the environment in which it takes place. So for people who use robotic devices like exoskeletons, prosthetics, it becomes necessary for the device to understand what the human is actually trying to do so that it can provide tailored assistance. I am a science fiction fan, and I have watched all Iron Man movies. I'm a super Iron Man fan, and I always wanted to work on exoskeletons. And more importantly, I think the work that we are doing is trying to solve real-world problems, helping people walk, helping people redo the stuff that they cannot do after injuries, and that's what's really interesting for me.
I currently work in the STRIDE group studying underwater robotics and autonomy. I'm working on the Selkie robot, including the next generation. Primarily what we're working on right now is all of the code and different patterns and algorithms that are used inside of our code to determine when do we walk, when do we jump, when do we swim.
One of the exciting things about what we do here is we focus on taking robotic systems, intelligent, smart machines with unique designs, and helping them prepare to operate in the real world. We have synthetic machines and we have rules that they follow, but once you get out into nature, once you get out into the real world, life gets really messy and complicated, and being able to tackle those challenges is what motivates us.